Hi everyone, this is a video specifically for this year's Year 13 with your exam tomorrow morning, or it might be in the afternoon, I'm not quite sure. But I've run out of time a little bit today trying to get you some revision resources. I've done quite a few videos, so I hope those are useful. But I just thought I'd do one about the theory stuff that could catch you out in the exam, because AQA have been absolute muppets this year, and they seem to like putting in really obscure strange bits of theory that could lose you a few marks here and there. We all know the maths is absolutely awful, and I'm going to be writing a letter of complaint about the maths that's in the exams, but sometimes they put in really small little bits of theory. For example, precious metal clay on the first one, which was a tiny little bit in the book, but there was, all of those marks add up. So I thought I'd do a video really quickly just to take you through some keywords. I've looked in the whole second part of the book, the designing, the paper 2 sort of section, and I've tried to pick out things that I thought might catch you out. So here we go. So in 2.3, the only thing that I've not covered in very much detail, I've done new manufacturing processes. These are the materials that are listed. Now, surely they're not going to put another precious metal clay question in. Glulam is timbers laminated together. They're laminated together. It's not quite the same as plywood. It's actually really chunky bits of wood, kind of like this, but they're actually glued together. So there'd be like another one there and another one there. I think we've done this in a mock before, but basically this is a really good alternative to things like concrete, and it's used in things like bridges, arches, interior design. Very strong. Nanomaterials you might want to have a look at. These is big developments in nanomaterials, things like graphene and things like that. So have a look at nanomaterials if you're unsure about that. Most of you probably are, so maybe have a quick look on YouTube about nanomaterials and get a little bit of information behind you. Kevlar is used in bulletproof vests. The big advantage of it is that it's wearable, flexible, makes it excellent for things like body armor, but it's ridiculously tough. So those are the materials that could potentially catch you out in that first section. So we've gone through very quickly the materials that might catch you out. These are some design strategies that could catch you out. Iterative or iterative design is where design goes in a circle of continual improvement. So rather than researching, designing, making and evaluating a product, you constantly get feedback from your client, and that means kind of gradual improvements are made. We've all done this in your NEA. You've designed, you've taken it to your client, they've suggested improvements, you've redesigned it. You've taken it to your clients, they've suggested improvements, you've redesigned it. So that's what iterative design is. Lots of small improvements to a product. Okay. User-centered design is very much to do with the NEA as well. It's where your main bit of feedback is coming from your user. You are going to be doing interviews. You are going to be analysing their needs and their wants from the product. You might carry out something called empathic research, where you do some research into how they are experiencing the problem. But user-centered design, I know that you've covered that before because that popped up in some of your NEA, so make sure you're happy with that. Then we have ergonomics and anthropometrics. Really, we should be happy with these two. So ergonomics is the kind of study of how products are designed to be designed to fit the human body, makes them easier to use, but also intuitive. So it can be to do with the shape and making sure that's comfortable. It can be to do with the use of colour. It can be to do with how much it weighs, the sounds it gives off, you know, all different types of things, ergonomics. And anthropometrics is the average measurements of the human body. So anthropometrics and ergonomics work together. In anthropometrics, you may have heard of the 5th, the 50th, and the 95th percentile. So the 5th percentile is designing, if it were talking about people's heights, the 5th percentile would be the shorter side, the 50th would be the average, and the 95th would be the taller end of the demographic. Okay, these are some strange design methods, one called Scamper, which I used in my design degree. I've never liked it, but it's a way of coming up with, it's a way of developing design ideas, development of design ideas. Thinking hats, which you'll probably remember from primary school, but it's a way of considering things from different points of view. And I've got a few slides to talk about this in a second. And collaborative working, bringing in lots of experts from different fields. So, for example, if you were designing a car, you might have a designer, you might have a mechanical engineer, you might also have an electrical engineer. You might have marketing. So you're bringing together everyone's skills to result in a much more successful product. It also means that you can work alongside each other, which can speed up the process of producing a product. So Scamper, this is Scamper. So I always remember when I was in university, I was given a traditional vacuum where you had the handle at the top. Believe it or not, this is a vacuum. You had the bag of the vacuum, you have the head of the vacuum and the handle at the top. And the idea was that you use Scamper to redesign this vacuum. So if you were using a Scamper technique to redesign something, the first S stands for substitute. So could you replace something with something else? So for example, the bag could be replaced with a cyclone technology, just like Dyson did. Could it be replaced with a different thing or a different concept? So you'd substitute something. The C in Scamper stands for combine. Could you combine things together? Could the handle and the bag be combined together? Could parts of the material be combined together? Or different things that usually have different functions, could they be combined? The A stands for adapt. Could something be adapted to do something different? Could you reshape the handle on the vacuum? Could you give something a new purpose? So could the head of the vacuum also do something else? The M stands for modify. Make something, you could make it bigger by magnifying it. You could make it smaller. You could change the colour. You could change the form. You could make it larger, smaller. So it's modifying the part that you've actually got. The P in Scamper stands for put it to another use. Could you change the location of it or how it's actually used? The E in Scamper stands for eliminate, get rid of it. Do we actually need the bag on the vacuum? Do we need the handle? Does the head have to do what it currently does? Could we get rid of parts? And the R stands for rearranging, changing the order of it, changing the pattern, the layout. So this is all ways of developing designs. So quite often when I ask a student to develop an idea, they've got no idea what to do. Like, well, how do I change it? You could use this Scamper technique to combine things, to eliminate things, to rearrange things. So it's a design technique helping you to develop ideas. Right, this is thinking hats, and the idea is that there are lots of different coloured hats, and imagine you are evaluating something or thinking about something. You would put on your imaginary different coloured hat and you would consider different aspects. So you could be in a design group that you are all thinking about a certain issue of how to solve a problem. The person with the white hat on would think about the facts of the issue. The person with the red hat on would consider the emotion, so how it might impact or how it might make people feel. The person with the yellow hat might think about the benefits, how solving this issue is going to be beneficial. The person with the green hats is going to think about potential ideas, so be quite creative. The person with the blue hat is going to be very much the planner, thinking about the objective and a strategy. And the person with the black hat are going to be the people almost playing like devil's advocate. I don't know if you've heard that before, but giving you judgments, making you see it from different points of view and passing judgment on, is that going to be good? Or have you thought about it from this point? So thinking hats is just using a variety of different techniques, and it's simplified into this idea of having different coloured hats that you put on, which makes you think of things in different ways. Right, I've looked in the chapter 2.7, which is all to do with accuracy. There are quite a few things in there. What I would suggest is you think about how you've been accurate in your NEA. So using things like the vernier calipers to take measurements when you were using things like the lathe. But also, we've done these before, the use of jigs, the use of fixtures, and the use of templates in manufacturing. So jigs actually guide a tool. So for example, you might need to drill holes in a particular place on every single piece of material. You might have something like this, for example, that goes over the edge of a piece of material. The drill goes through these holes, meaning that the holes are drilled in exactly the same place on every single piece of material. So a jig guides a drill or a cutting tool to make sure everything is accurate. Fixtures hold a component in place as it's being worked on. So I've shown you examples before about things like car doors being held in a fixture so that a variety of different machining operations can be carried out. Things can be drilled, things can be attached. So it's basically a fancy clamp to make sure that pieces of material are not moving around, and all of these are to remove human error. And templates are as easy as they sound. Things that are drawn around to make sure things are cut out the same every time. And if you think, why do we use templates? Well, again, it's to remove the human error, speeds up production. You're not having to measure things, it speeds it up, it's less human error, and things are going to be much more accurate. Right, responsible design. This is another focus in the exam. There is nothing very complicated in here at all. Make sure that you know your 6 R's. So we've got reduce, reuse, recycle, rethink, repair, and there's always one I forget. 1, 2, 3. I always get to 5 and I can't remember the 6th one, so maybe look into it and find out the one that I've forgotten. You need to know about carbon footprint. So this is like a sustainable, like a life cycle, not marketing life cycle of like how CO2 is produced. So everything from the extraction, you've done this in chemistry and GCSE, to the manufacture, making it, to the use, to it being recycled or disposed of. CO2 is produced in all of those different areas. And in the book, it's listed as primary carbon footprint and secondary carbon footprint. All this means is primary carbon footprint is the CO2 produced from the making of the product, and secondary carbon footprint is from the use of the product. Okay, you need to be happy with the different types of renewable energy, things like solar, wind, things like that. And circular economy, I've done a separate video on, so have a look at that if you're not happy with circular economy. Right, this is a big old chapter in the book, and it's got a lot of things that are a bit odd in terms of their definitions. So this could come up in smaller mark questions. So what I would recommend, I'm not going to go into much detail about these now, but you might want to watch a few YouTube videos, do a little bit of research into the definitions of these terms. So the main kind of things that you need to know in this area, and hopefully you've covered these before, quality assurance. Quality assurance is procedures that are carried out at the beginning, before you even start making something, beginning of manufacturing, to make sure that you've got everything in place. So have you got the right training? Have you got the right equipment? Have you got testing procedures in place so that products are made right first time? That's the kind of thing about quality assurance. It's making sure that you make things right first time. Okay. And since I'm talking about quality control, I'll talk about quality assurance. Quality control are checks made on the product rather than the manufacturing systems. It's on the product during and after its production. So it could be a visual inspection. It could be using a laser scanner to check the dimensional accuracy. So quality control checks are done on the actual product. Total quality management, sometimes shortened to TQM, is getting the workers involved in all aspects of the production, getting their feedback, and constantly making sure that you are making improvements to improve quality. Six Sigma is a strategy used again to identify issues in manufacturing and in terms of quality. If you've never looked at Six Sigma, I would look at YouTube for this one. I'm sure you'll find some good videos on Six Sigma. Same with critical path analysis. This is all about streamlining the manufacturing process. So for example, can tasks run at the same time as each other? So if you were making a car door and you had to press form the car door and then attach whatever to it, can things be running at the same time? For example, can the electronics be being made? Can other things be being made so that everything is sped up? So that's critical path analysis. I would have a look at both of these. Look at some YouTube videos, look at some definitions. These two could catch you out, definitely. Tolerances, acceptable range of error. In manufacturing, a go, no-go gauge is used. If you're not sure what one of those is, I would have a look at that. And non-destructive testing can be used at this stage as well. So things like ultrasound can be used to detect like cracks or issues in a product. So non-destructive means you're not breaking it open, you are doing some checks on it to make sure that it is suitable. So if I said anything, I would have a look at any of these that you don't know. Have a look at these, very, very important. Last one that could potentially catch you out, it's not a focus but could be in the lower mark questions, are these international standards and national standards in product design. So going to whiz through these really, really quickly. ISO linked to BSI can sometimes be to do with safety standards, and they are international standards. They are rules to be followed. This one, restriction of hazardous substances. This is things like mercury, chromium. This came up in a mock once, and it's making sure that these materials are not being used in products, because if they go into places like landfill, they can be very, very damaging to the environment. So that's what that's all about. The battery directive is to stop batteries going into kind of main and general waste, because the chemicals can leak out. That's what the battery directive was all about. So batteries are now put into different bins and they are split out. Polymer codes are those numbers on the bottom of plastics. They are recycling codes. They mean how widely recycled polymers are, and basically the higher the number, the worse it is. So a number 7 means it's not widely recycled and means it's likely to go into landfill or have to be burnt, which can obviously be damaging to the environment. You have something called a packaging directive, which is to reduce the use of finite resources in packaging, so things like polystyrene. We've got this one, the WEEE directive, waste from electrical and electronic equipment. So making sure that they are put, so when you go to a recycling centre, or the dump that I used to call it, there is a separate area for things like microwaves, PCs, laptops, because a lot of these products contain very, very valuable resources, a bit like the circular economy really, valuable resources that need to be recovered. Okay, the EC energy label and eco labeling, these are labels that tell you how energy efficient products are. So you might see them on things like your TV or your washing machine. It might give it a rating out of like A, B, C, D. You might want to have a look at that if you've not seen that before. FSC is the Forest Stewardship Council. If you see that logo, which again looks like a tick with a tree like that, FSC, it means it's coming from a sustainably managed forest. And the EU Energy Star, it basically means that across the EU, this is achieving the standard for energy. So it's a good example of an energy efficient product. So it's a label, a sticker that a product would be able to achieve. And by getting all of these stickers, obviously you are going to improve your sales because customers want products that are more energy efficient and better for the environment. Right, that is a massive whiz through of things that could catch you out in the exam. Please, any of those that you have no clue about, do a bit more research, watch a YouTube video, have a look in your textbook. I hope that was useful, and massive, massive best of luck for the exam tomorrow. See you guys.